Hi everyone. At this point, you should have completed the last question on angle of elevation, and you're ready to start our next question, which is on an angle of depression. Okay. So this example says Cameron is out on Coventry Lake during crew practice. Mason is standing outside of a house 600 feet away. If Mason is looking at Cameron at an angle of depression of 4 degrees, how high above the lake is Mason standing? So similar to an angle of elevation, is an angle of depression. So try to make a prediction right now. What do you think that would mean? If an angle of elevation measures up from the horizontal line to a line of sight, what do you think an angle of depression could mean? And hopefully you're thinking that it is measured now down from the horizontal line to the line of sight. So here's an example of a person in an airplane, and the angle of depression from this person looking down at something, looks like in this forest, is 45 degrees. Again, the important thing about this definition is that it starts at a horizontal line. This is the part that students make mistakes with every year. It has to go from a horizontal line and measure down from there, and that is known as an angle of depression. So in this diagram here, the angle of depression is 45 degrees. And now, that's not a 5. And something that will help you guys when it comes to solving questions on angle of depression is noticing the relationship between an angle of depression and an angle of elevation. So the cool thing is, let's say I had an example here with a person down here on the ground and someone up here in a hot air balloon. So the angle of depression, again, from the horizontal line measuring down from there, is 38 degrees. But that would be the same as the angle of elevation from the person looking up towards the hot air balloon. And the reason why is, think about these two horizontal lines. If they're both going straight across from left to right, they have to be parallel to each other. So then we have this line that kind of connects or intersects those two parallel lines. We've called that a transversal in the past. And then these two angles that are on opposite sides of the transversal, but both in between or inside those parallel lines. Yeah, these angles are going to be alternate interior. So that's why an angle of depression will always be congruent to an angle of elevation down here in the diagram. Okay, so the reason I bring that up is because in this example here, you're going to see how that kind of comes into play. So let's start. I'm going to draw both Cameron and Mason. So Cameron is on, was it Coventry Lake? Coventry Lake. So I'm going to have Cameron standing down here. Okay, that's Cam. And then Mason's up here, right, looking down towards Cameron. And then there's Mason. You guys look very similar. So again, if I'm drawing an angle of depression from Mason down to Cameron, I have to make sure I'm starting with the horizontal line straight across, and then it's measuring down from there towards Cameron. So again, that angle of depression was told that equals 4 degrees. Okay, 4 degrees of that angle. And now I'm trying to figure out how high above the lake Mason is. Well, Cameron's on the lake, right? So I'm going to figure out basically how far down from there Mason is. And there's our right triangle. There's my right angle. And we know we're trying to solve for how high above the lake Mason is. So I'm going to call that X. Okay. The other thing we know is that Mason is standing outside of a house 600 feet away from Cameron. So that's the straight distance from Mason to Cameron. So I'm going to label that over here as 600. Now what you might notice is that this 4 degrees, my angle of depression, isn't located inside the triangle. Well, how can we use trigonometry if I don't have the angle inside the triangle? And that's where that connection I just talked to you guys about, where the angle of depression is congruent or the same to the angle of elevation. So since this angle up here is 4 degrees, I know down here, over where Cameron is, will also be 4 degrees. And now we can look inside this triangle to use trigonometry. All right, here's my angle of 4 degrees. X is across the triangle from that, so that has to be my opposite. We have 600, which is the hypotenuse. Okay, which trig function uses opposite in hypotenuse? Well, it's going to be sine. So we're going to say sine of our angle. So sine of 4 degrees is going to equal opposite over hypotenuse. Multiply both sides by 600. So we get 600 times sine of 4 equals x. Okay, since we're multiplying here, if you have normal calculator, just multiply 600 times sine of 4, or if you have an Android phone and you're using that calculator, if you're using an iPhone, going to have to kind of switch the 4 and the sine. So you can set 4 sine and then times 600. But either way, you should get a height of 41.85. So I'll round that to 9 feet. Okay. And at this point, now you can move on to the next problem.